Today we are going to talk about the sector of a circle. What a sector of a circle is a region bounded by a central angle and an intercepted arc. So your central angle, remember, is your theta. The arc, that's your s. So looking back over here, we have arc length s, radius is r. We need to recall that the circumference is 2 pi r of a circle, and then the area of a circle is pi times r squared. Now, I like to think of a sector of a circle as a slice of pizza. Right? The crust of the pizza would be your arc length. Now, if I have a pizza, and let's say my slice of pizza measures 60 degrees from the center. Right? Well, 60 degrees is a fraction of the circle. 60 out of 360, which is the total degree of a circle, is 1/6 of the circle. Therefore, I can calculate the arc length, which is the outside, the distance on the circle, as 1/6 of the circumference. Or I can calculate the area of the circle as 1/6 of the area. That brings us then to some formulas. If I am talking about the degrees, so if theta is in degrees, I can take my degrees out of 360, because there's 360 degrees per circle, times that by the circumference 2 pi r, and it'll give me the fraction of the circle, which we call arc length. If I take my degrees out of 360 again, and times it by pi r squared, which is the area of a circle, it would give me a portion of the area of that circle. And area, in this time, we are going to use K to represent area. Now, if I'm talking about theta and radians, we learned a formula the other day that S equals R times theta. Given that formula, I can use it to derive my area formula. To begin with, I first have theta over 2 pi, because one circle is equal to 2 pi radians. If I times that by the area, pi r squared, what happens is the pi's cancel, and it equals to theta over 2 times r squared. To write this a little bit nicer, we can pull the 1/2 out in front and say 1/2 theta r squared. Now, we know that theta times r squared is like r times r. And given that s equals r times theta, I know theta times r is s, times that by the radius. I can then rewrite the area formula as 1/2 rs. So both of these formulas are area formulas for radians. Now that we have some formulas in front of us, let's try some examples. For the first example, it says the sector of a radius is 5 centimeters and a central angle of 0.7 radians. Find its arc length and area. To begin, I'm going to label what I know. I know that the radius is 5, so that's my r. The angle is 0.7 radians, that's my theta. I'm trying to find arc length, which is s, and area, which is k. So to begin, I can use the s equals r theta formula, because I have a radian formula, and therefore you give me 5 times 0.7, which equals then 3.5 for my arc length. And arc length is a distance, so I'm going to label it with centimeters. Do not forget to label. The area formula that I can use, which is k, I have my radius, and I also now have my arc length, so I can use 1/2 rs. That would give me 1/2 times 5 times 3.5, multiply that together, and I have my area of 8.75. Area is labeled then with centimeters squared. So now I have my arc length and area that I was asking for. For example 2, it says the arc length of a sector is 6 centimeters, so my s is 6. The area is 75, so my k value is 75. I want to find the radius r and angle theta. Now, for the formulas, what I could use, I know that s equals r times theta, but I can't do that quite yet because that would be 2 unknowns. I can start off though with the area formula. Area is 1/2 times r times s. If I start off with the area formula, I have just one unknown, the radius. If I simplify this, I know half of 6 is 3. Divide both sides by 3, I get the radius to be 25. And radius is the length, so I'll label it with centimeters. Now that I have the radius, I can then go and find theta. Using s equals r times theta, I can rewrite this as theta equals s divided by r. So my s value is 6, my radius I found was 25. If I divide this out, I get theta to be 0.24, and this is a radian measurement because s equals r theta is a radian formula. If it said it wanted degrees, I could take my radians, multiply it by the conversion factor, 180 over pi, and I would get 13.75 degrees. So I got my radian measurement for theta, and I can get the degree measurement by using the conversion factor. Our next example, it says the central angle is 25 degrees, that's a theta. The arc length is 2.6, so that's my s value. I want to find area. Now the area formula for degrees is theta over 360 times that by pi r squared, the area of a circle. If I fill in what I know, I have 25 over 360 times pi and then the radius squared, but I don't know the radius. So how do I get the area? Well, using this arc length, I have to somehow find the r value, the radius. The arc length formula, given degrees, is theta over 360 times the circumference, 2 pi r. So using this, I can plug in 2.6, 25 over 360 times 2 pi r. If I multiply together what I have, I get 2.6 equals 0.436 times the radius. So I'm going to divide both sides by that value. And then I get the radius to be 5.959. Using this known value, I now can plug it back into my area formula and calculate the area of my sector. So multiplying together 25 over 360 times pi times the radius squared, I get 7.75, and it's an area, so I'm going to label it centimeters squared. And now I have the area I was looking for. Example 4. It says to find the radius and the arc length, given that you have the perimeter and the area of a sector. Now, a sector, we know, looks like a slice of pizza. You have the radius and then the arc length, and that's from the center of a circle. So therefore, I know the perimeter of a sector is the 3 sides added together, or simply put, the perimeter equals 2 times the radius plus s. Well, in this perimeter, it's 16. So I know 16 equals 2r plus s. Now, I do need to find both the radius and the arc length. But we know from Algebra 1, if you have 2 unknowns, you have to have 2 equations. So my second equation comes from the area. My area formula is k equals 1/2 r times s. I'm using this formula because it has r and s in it, which is the 2 variables I'm looking for. If I replace the area of k with 15, I have 15 equals 1/2 times r times s. Now, since I have 2 unknowns and 2 equations, I need to use the substitution method to find the 2 unknowns. So substitution method, I need to solve for one of the variables. I usually solve for the variable that has the coefficient of 1. It makes the problem much easier. So I can rewrite s equals 16 minus 2 times the radius. I'm now going to plug this into s in the area formula. So 15 equals 1/2 r times 16 minus 2r. If I distribute, that gives me 8 times r minus that'd be 1r squared. Now, since it's quadratic, I do need to get to equal 0. So I'm going to add the r squared over, minus the 8r over, I have a positive 15, now it equals 0. If I factor this, I will have r minus 5 and r minus 3. Setting those equal to 0, that gives me the radius of 5 centimeters, and then the radius of 3 centimeters. So I did find the radius that I was looking for. I also need to give the arc length. Well, going back to my arc length formula, I know that the arc length would equal 16 minus 2 times 5, which gives me 6 centimeters. And for 3 centimeters, 16 minus 2 times 3 equals 10 centimeters. So I have 2 different radiuses and 2 different arc lengths. How could this happen? Well, think of a small pizza versus a large pizza. If I cut out a slice of pizza from the small to get the exact same area as a larger pizza, this pizza would have a larger arc length versus the large pizza, to get the same area of a slice of pizza, it'd have a smaller arc length. In the small pizza, this would be my radius of 3 and an arc length of 10. It has a larger arc length. In the larger pizza, the radius would be larger, that would be my radius of 5, and the smaller arc length of 6. So it is possible to have 2 different radiuses and 2 different arc lengths to get the same area. For our last example, we need to talk about apparent size. What apparent size is the measure of an angle. We're using apparent size, we'll be using S equals r times theta, the arc length formula for radians. So in the example, it says the apparent size of a building 2 kilometers away is 0.5 radians. So the radian measurement, that's my theta. I want to know what's the height. Well, using S equals r theta, am I supposed to know that the 2 kilometers is S or is it r? Here's a picture. If you're standing in the center of a circle, looking at a building, right, picture yourself standing in the center of a circle. Right? Now, the theta, 0.05, that's the angle that you're looking at the building from. If you're standing in the center then, and you're 2 kilometers away from the building, this 2 kilometers then would be the radius of the circle. So using S equals r times theta, I know the radius is 2, theta is 0.05, so my arc length, if I multiply those together, that would give me a total of 0.1, and the measurement was in kilometers. You could rewrite this and convert it to meters, timesing that by 100. And you could say the height of the building is 100 meters tall. So apparent size is S equals r times theta. The distance you're away from something, that's always your radius. Theta, remember, is always in radians. And that concludes the lesson.